JJ Math. We're going to look at linear number patterns. That's the normal number patterns you've been doing since primary school, where you just add something that's constant or you subtract a number that's constant. In this example on screen, we will just be adding 3 the whole time to get the next number. So if they ask you what comes after 11, you can just say, okay, I've been adding 3, so it must be 14. Okay, that is linear patterns. Let me show you a few other examples. There is one sometimes in a linear pattern, you can subtract a constant value. But the key feature of a linear pattern is that it is always a constant difference between the values. So if I say give me the next 2 terms in this sequence, it would be 8, then the next one would be 4, and then 0, and then it goes into the negatives. Let's look at another one. The sequence can even start negative and then go more negative. So in this case, again, I'm subtracting 4. So the next 2 terms would be minus 18 and then minus 22. Last example, I can start negative but then also add a positive value. So in this case, I'm just adding 3 the whole time. So the next term would be 7 and 10. So that is a linear pattern, the one that you've been used to since primary school. But now when you reach matric, they are going to teach you an official formula called the arithmetic sequence formula, or the Tn formula for arithmetic sequences. So many schools have been teaching this formula. I know personally I teach my students this as soon as I can because it just makes things easy to keep it constant with what you're anyway going to use when you get to grade 12. So in this case, Tn stands for the value of a term. A is always the first term. D is always the constant difference. And then N stands for the position of the term. Okay, so N is position. If I look at the number 29, I know its value is 29, but in the sequence, it's actually the 4th number in this linear sequence or this arithmetic sequence. Okay, let's say we did not know what the value of the 5th term was. So let's test if this formula actually works. Okay, so I want to work out what the 5th term is. I said A is the first term, so 1 plus, then I can count, I want the 5th term, so that's the position in the pattern. So in the place of N, I'm going to put a 5 minus 1, and then the constant difference in this specific sequence, I can see between 1 and 8, I'm adding 7. But let's say it was a bit more complicated. I want you to please remember this specific formula. Okay, D you always get when you take a term on the right minus the term just left of it. So in this case, I said term 2 minus term 1. So D would be equal to 8 minus 1, and therefore D would be equal to 7. So always a term to the right minus the term just left of it. Okay, so I'm going to put a 7 there. And when I multiply this out, 4 times 7, the answer is 29. And therefore I know the 5th term in this sequence is 29. Okay, wonderful. If they just asked me, get the Tn formula for this sequence, okay, that's a question you're going to get a lot, and the questions always start with, let's say it's question 3. Question 3.1 would most of the time be get the nth term. So what I'm going to say there then is Tn equals 1 plus, I'm going to keep the n there because they didn't ask me for a specific term. They just asked me for the nth term of this sequence. So I can fill in A and I can fill in D, and when I look at it, it's going to be 1 plus 7n minus 7, and therefore the nth term of this sequence is 7n minus 6. Now let's look at a typical way that arithmetic sequences are asked in tests or exams. Firstly, find the nth term. So I know I'm going to start with Tn equals A plus n minus 1 D, and in this case they don't ask me for a specific value or a specific position, so I'm just going to fill in what is A and what is D. So in this case A is negative 125, and D, like we saw in the previous example, I can take the second term minus the first term, so I'm going to say minus 153 minus, remember your brackets, minus 125. Okay, that would actually give me a value of negative 28. So to find the nth term, I'm then just going to sub in those two values. So I know A is minus 125 plus, I don't know what n is, so n minus 1, and then D, negative 28. And all they want from me is to just simplify this. So if I multiply in the negative 28, I'm going to see this is minus 28n plus 28 minus 125. So the final answer for the nth term of this linear sequence or arithmetic sequence would be minus 128n minus 97. That's the final answer for question 1, the general formula or the nth term. Now if I look at question 2, they are actually asking me what is the value of term 123. So they give me n in this case as 1, 2, 3. The position I now know, but I don't know the value. So that is what I need to figure out in this case. So I'm going to start my formula by saying term 123 would be equal to my a value. Sorry, not my a value. The formula I just worked out in question 1, I'm going to start with. So just going to fill in that. But I actually know what n is. So I'm just going to put in 123 in n's place minus 97. Now, you are in grade 12. You are really free to just use the calculator. And the answer here would be minus 3541. Therefore, the value of the term in the 123rd position would be minus 3541. Question 3, they are now swapping it. And they are giving me the value, but they are asking me the position. So in this case, if I just update my list up there, I don't know what n is, but I know the value would be minus 685. So I'm going to start again with my nth term, but in this case, I'm going to fill in the left-hand side. I know this is minus 685. That would be equal to minus 28. I want to work out n in this case, and I'm just going to add the 97. So once again, this is just an algebra sum. Use your calculator. By filling in the values and choosing the correct formula, you already have most of the marks for the sum. Now they are just interested in the answer. So the next step, I'm just going to take over the 97 and divide by negative 28. And therefore, my calculator tells me this is the 21st term. Okay, guys, I hope this makes sense and you understand arithmetic sequences a bit better now.
If this video helped you, please like and subscribe.
JJ, man.